Does that work from the sound volume? Cool. All right. All right. Thank you very much. Also, thank you very much for the organizers. This is really cool. Really good to have a whole talk on libp2p, obviously, and then also a whole conference around peer-to-peer networking. It's very exciting. All right. Okay. So today, or in this talk, I want to give you an introduction to libp2p, and then also for those already familiar with libp2p, but also that are those that are now already familiar with libp2p, to talk a little bit about the state of libp2p itself. Cool. All right. Small introduction from my side. Not the best libp2p developer, software developer at Protocol Labs. I'm stewarding the libp2p project, among others. We should have Martin somewhere here. Over there. Cool. We have Marco. Cool. We have Melanie over there, and Elena as well. So you pretty much have, from the Protocol Lab side, the whole libp2p team here. So yeah, we'll stick around as well. So plenty of time for questions, suggestions, and so on. Cool. So stewarding the libp2p project. I'm part of the Rust side of libp2p, so I'm maintaining the Rust implementation. All right. So what is libp2p? Before I explain what libp2p is, kind of want to know, like, who's familiar with libp2p? Who's heard of this before? All right, a lot of hands. Who has worked with libp2p? All right, cool. Love it. All right, so what is libp2p? I'll still do an introduction to all of that. libp2p is a modular peer-to-peer networking stack. And the big slogan kind of is like, it's all you need to build peer-to-peer applications. And that's a big slogan, obviously, and we'll go into a lot of little details on how we fulfill that, right? The important part here is composable. So in the end, you can build your building blocks into a larger application and then use that in your peer-to-peer application. It has a shared core. And then there's a lot of built into libp2p that makes it future-proof in the sense that we can evolve protocols in a very nice manner, which is super important in peer-to-peer world, as it's not like you're pushing an update to your server, but instead you need to convince, I don't know, 1,000 people out there to please upgrade to the next version. Right? Okay. libp2p, it's a large term. We use it for a lot of things. In the end, libp2p is a specification. And then libp2p itself is the specification is implemented in roughly 7+ languages, and we'll go into a couple of the languages. So that's really exciting. Like, we have the spec on the one hand, and then so many people working on it in so many different languages, enabling so many people in different languages to then write their peer-to-peer applications. All right, based on the fact that libp2p is written in so many languages, it also targets a lot of environments, like, for example, browsers, mobile, embedded. It will run on your server, it will run on your laptop, pretty much anywhere. Big users, I have a separate part for the users as well, but number one, IPFS. libp2p is born out of IPFS, so it's quite obvious that IPFS is using libp2p. Then we have Ethereum 2 building on libp2p, we have Filecoin building on libp2p, we have Polkadot building on libp2p, we have Bertie here building on libp2p, and many, many more, right? So quite a lot of online nodes at any given point in time. I'm estimating something around 100,000 at any point in time, though that is really, really hard to do, as on the one hand, it's an open source project, so everyone can use it, and we're not aware of everyone using it. Who's all using it. And then also it's in a peer-to-peer world, so it's really, really hard. You can ask a couple of the libp2p engineers here to measure, like, who's all using libp2p and how many nodes are actually active. All right, so where does libp2p live? I said libp2p is all you need to build peer-to-peer applications, or to build your peer-to-peer application. And in the end, libp2p builds on top of your operating system network stack, and then gives you all the abstractions that you, as an application developer, has to no longer worry about TCP connections or who you're connected to or how to secure that connection. But instead, you have like a peer-to-peer interface of basically saying, hey, I have this message. Can you please gossip that to the entire network, right? And then libp2p, for this example, takes care of the rest. I want to go into a couple of, I said libp2p is built of many building blocks, right? I want to go into a couple of those. Definitely not all of the building blocks. We don't have like a week here. But first off, I kind of want to explain to you how libp2p has like point-to-point connections. So how we actually achieve to exchange bytes from A to B. And then also talk a little bit about the peer-to-peer abstractions that we can build on top of those point-to-point connections. So let's first go into transports. And well, libp2p is a networking library, so we actually want to get bytes from A to B. How do we do that? We use transport protocols, right? So most important abstraction in libp2p. Today, we support TCP and QUIC and WebSockets, and there's experimental support for all kinds of different other things. For example, we have WebRTC. I think we have a talk on Bluetooth as well. Yeah, okay, cool. So a lot of transports out there, we're targeting more and more and more. Yeah, that enables libp2p to get bytes from A to B. All right, so well, now that we can send bytes from A to B, we want to secure whatever bytes we want to send, right? So libp2p right now has to offer a couple of core security channel abstractions or upgrades. So noise being, I think, the one that's supported by most of the implementations out there, and then also TLS, which you can use. I think there are a couple more, but I'm not too familiar with them. All right, so now we can exchange bytes. We can secure those bytes, right? We can encrypt them, authenticate, and so on. Next step is for us to multiplex a connection. Multiplexing a connection is basically taking a connection and running a bunch of virtual connections on top of that single connection. Now, you might be asking, why not just do a lot of TCP connections or quick connections or whatever have you? Connections are very precious in the peer-to-peer world. I have a whole new block on that in a little bit, why they're so precious. Just as a mental model, like we don't communicate to a single server, right? And so for that, we would, for example, only have a single connection. But we're communicating to a whole network, to all our peers. So that's already a lot of connections. So we need to treat every single one as very expensive. And then on top of that, we have NAT Traversal and so on, which we'll have in the next step. So a lot of motivation to make great use of a connection. And what we're basically doing is multiplexing each connection so that each peer-to-peer protocol, the ones on the building blocks on the right, then can use basically their own connection. So there we have Yamx and Mplex, but then also, for example, QUIC has multiplexing built in, or WebRTC might in the future. Yeah. All right, send bytes, we can secure them. We can multiplex a connection, so a byte stream. Now, why are connections so precious? Again, we're in the peer-to-peer world, and also the internet is kind of difficult for peer-to-peer, namely because due to NATs and firewalls, right? A little bit of a motivation why we actually want to overcome those NATs and firewalls. Most networks, I would say, have most of the nodes not actually in data centers well connected, but actually in some kind of ISP setting, home setting, where they are behind a NAT or a firewall, right? And somewhat dated measurements, 2019, showed that basically 63% of the IPFS DHT we couldn't reach, right? And that's not very cool for for a peer-to-peer network. So NAT Traversal is definitely a big thing for us. We shipped this in Go in end of 2021 and in Rust in, beginning of 2022. And other implementations are following as well. We can do NAT hole punching on TCP and QUIC now. Basically, for those familiar with ICE, we're using basically a turn adaptation and then a stun adaptation. And we can do all of that in a decentralized fashion, which we have a whole talk about tomorrow. So I won't go into great detail here. Yeah, next step would be to also support WebRTC for hole punching. and a couple of other protocols. Cool, all right. I'll recap this. You can't, yeah. We have transports, we can exchange bytes, we can secure those bytes, we can multiplex those connections, those streams of bytes, we can actually hole punch through NATs and firewalls. So now we have everything for point-to-point connectivity, right? And now we could stop here as libp2p and say, like, that's all you need to do peer-to-peer applications. Doesn't sound about right. So we have a bunch of building blocks on top of this. And the first one I want to go into is how to actually discover other nodes within your peer-to-peer network. So if you start your application, you probably want to reach out to many peers around you. There are many different ways to do that. First off, you would probably connect to a bootstrap node, or when you're in your local LAN, you would do multicast DNS. For those not familiar with that, it's basically how you discover your printer in your home network. We have more federated models like rendezvous servers, where a bunch of servers peers connect to and then discover other peers. But also we have peer discovery built into other protocols, like for example GossipSub, where I think if you leave a set, someone also tells you other peers to potentially connect to. Cool. Now that we discovered a bunch of peers, we might want to find a specific peer, or we might want to find a specific peer providing certain services. And that's where libp2p offers you a routing protocol. Most notable, Kademlia. For those not familiar with Kademlia, it's a distributed hash table. So it's basically a hash table, but distributed across your peer-to-peer network. Highly recommend reading the paper. That's not libp2p specific, but it's a very, very, very neat paper here. What it enables you to do is, as a peer, you can find another peer by its peer ID, or, for example, you can, as a hash map does, save values by the key, or you can find providers of a certain service, and that's rather abstract. In the IPFS case, that would be you're searching for a peer that provides a certain file, right? And then you can find that peer over the Kademlia DHT and then connect to it, for example, as one use case. Cool. All right, so we discovered peers. We're able to route to specific peers. Next one we offer is messaging. And in general, libp2p offers like a pub/sub interface. So publish, subscribe. You publish to a topic to those that are subscribed to that topic. The most notable implementation here is GossipSub. Again, recommending a lot of papers here. I think the paper is a really good read to understand GossipSub. We have a whole talk on this, so I won't go into details here. In the end, what we want is basically, a pub/sub mechanism in a peer-to-peer world. So we don't have a single broker, right? We don't have an authority in the network. It needs to be self-regulating in the sense that, there's no authority that regulates the network from the outside, and there's no global knowledge as, consistency is hard, especially in peer-to-peer networks, and no single peer has a global view over the entire network. All right, and then I think Yannis will go into a couple of defense mechanisms that are built into this protocol, which is really exciting, enabled by like eagerly pushing data to nodes they're interested into, but also you as an interested party to lazily pull data from other peers. Okay, but whole new talk, I think later today. Yeah, okay. All right, so we were able to discover we are able to route to specific peers. We were able to do the messaging. Another cool feature is data exchange. You want to exchange big blobs of data. You could obviously just send it to a single peer if they request it, but there is a lot of smarter ways to do these things. One of them in the libp2p world is bitswap. Another paper to read. It's a message-oriented protocol, and it's a little bit smarter around how you retrieve large blobs of data within a network. I'm happy to go into detail afterwards, but I think that kind of is too much for the introduction. Cool. All right. That are all the building blocks. I'll go through this one more time. We are able to exchange data, bytes. We can secure those data streams. We can multiplex connections because connections are precious. We can do NAT traversals. We're in the peer-to-peer world, so unfortunately we have to. We can discover peers when we join a network. We can route to specific peers, and we can route to peers that offer certain services. We can do messaging, and we can do data exchange. And I would argue that is all you need for building your peer-to-peer application. All right, so now more towards the part of not what is libp2p, but where are we at right now. I said it's mostly a spec and then implemented in many languages. I think at least the oldest implementations is Go. It should be JS above that. Actually, JS should be at the very top. And then Rust. Go is definitely, in terms of feature completeness, like far ahead. Rust libp is trying to catch up. JS libp2p is targeting both the browser world and the Node.js world. Yeah, so kind of use cases for that. And then there are many more implementations, like, for example, a C++ implementation, JVM, NIM, Python, Erlang. I think there are more. So yeah, a lot of people building in many different languages. I mentioned a couple of projects that are using libp2p. I want to go a little bit into that. IPFS, obviously, as I said, the history of libp2p, actually libp2p being born out of IPFS. Again, it's very hard to measure peer-to-peer networks and their sizes. And like, for example, my crawler discovered basically 70,000 nodes within 12 hours, which is a really huge network in my opinion. Okay, Ethereum 2, not as large, or maybe we're just not discovering all of the nodes, but a really cool story about Ethereum 2 here is, well, Ethereum 2 is implemented in many different languages, right? But what that means is that all of these language implementations use their libp2p implementation in their language, right? So you actually have this huge network of Ethereum 2, like where all the different libp2p implementations interoperate. And this is a live network. Not live network, but this is an operating network, which is really cool. Filecoin has the interesting use case of, like, well, actually having to send a lot of data. So that's a really cool use case for Filecoin. Then Polkadot, which was one of the drivers of the Rust implementation, for example. And then the one project that I usually use to explain to folks what libp2p is Bertie, like the perfect use case for peer-to-peer networking library. Okay, many more projects, just a couple of highlights here. So where's libp2p heading? libp2p is heading in many, many different directions. I can only really comment on what, like, protocol apps will focus on. And then a lot of the different community activities or directions that community is going into, or the larger community, like we'll hear a couple of talks here, and then yeah, a lot is happening online on that. We have a roadmap in the libp2p specs repository, and it doesn't have to be the protocol apps roadmap. If you have comments, if you have suggestions, like, this is the place to discuss where libp2p is heading. I picked a couple of examples out of that. The first one is NAT punching. We have that pretty much spec'd, implemented in Rust and Go. But for example, WebRTC would be really cool for NAT punching to have as well. Then long term, we would like to replace an old friend of ours, which is multi-stream select. It served us very well, but we can save on a lot of round trips here, and round trips is super important in peer-to-peer networking, obviously. So that's a big project for ours. And then improve browser connectivity. That's the whole WebRTC story, but also, for example, web transport, very fancy protocol. Martin will go into that. And then WebSockets around that. Cool. So yeah, get involved if you want. All right, that's all from my side, from the libp2p side. But one other kind of shout out in the void I want to do is libp2p is open source. There are the many implementations out there, but also libp2p is open for any collaboration or contributions, right? So in case you want to get involved, well, in case you're already involved, very cool. In case you want to get involved, like you have a bunch of folks interested in libp2p in general here. You have a bunch of folks from our side here as well. You find the documentation online. We have a discussion forum. Most of our specification and high-level discussions are happening in the public on the specs repository. You have the many language implementations. And then lastly, every other week, we have a community call for you all to join. Cool. That's all from my end. Thank you very much.
Thank you. Thank you so much, Max. We have time for like 1 or 2 questions. Are you good? Yeah. Yeah.
Okay, thank you for your talk. I have a question regarding routing in the real internet. There's BGP protocol. Is there a similar thing for peer-to-peer, or do you not need it?
So currently, we're pretty based on the IP stack, right? And then the IP stack, I mean, you don't know what ISPs are using under the hood, but probably BGP to actually route the packets, right? Or at least to navigate the routes. Do we need it? We have it on the roadmap, like for future consideration, whether we want to have, like, for example, overlay network for packet routing. Where we need it today, and what I would compare it to is Kademlia, right, the routing protocol. But it is like, yeah, very different to BGP, right? Where BGP, you build trust between ISPs. Yeah.
I mean, to reach hosts that you're not directly connected to.
Yeah. Okay. We depend on IP for that. Yeah.
Another question? Come on, guy, don't be shy. I'm gonna pick someone random if there is no question. No? Yeah, there is one.
2 questions. One is, what are you most excited about personally? And second, if people are like just getting their feet wet with peer-to-peer, what would you recommend for them to like do and try out as they explore peer-to-peer systems and get into like building things?
So what I'm most excited about is the whole browser connectivity part. Like, yes, libp2p works in many scenarios, but like browsers are the platform, and we need to get them to be able to connect, to be first-class citizen within the network. And that is huge, like to have every single browser be able to connect to any other node, potentially even other browsers by hole punching. So that's the thing that I'm most excited about. Then how to get involved. I would say build something with libp2p. Like many of these resources give you like guidance on how to build things with libp2p. Build something with libp2p, find bugs, report those bugs, and then we help you to fix those bugs. Or, yeah, we fix those bugs. That's it.
Anyone? Yeah.
Thank you for the presentation. If I would explain a libp2p stack to someone from Web 2, where should I start? And what's the major benefit for them to use it if their solution is already running?
Yeah, so I usually, when I explain libp2p to someone, I'm guessing technical, I usually start with a standard, like, you have one of the big chat platforms out there, right? They all communicate to a central server. Wouldn't it be way cooler if the 2 devices communicate on the shortest path? And that's where I go from there. Okay, what's the best place for them to get started to transfer to a Web3 world? Yeah, start super small. Like maybe, for example, like we have a couple of shortcuts in libp2p. Like for example, on what was it, peer discovery. Like Yeah, sure. You can, for example, use the Kademlia DHT and then explore peers and everything, right? But what you can do instead, as a first step, you use the rendezvous protocol. You have this one central server, right, where all your peers connect to, and then slowly you migrate away from that, right? So use shortcuts, go slow, like, and then at some point end up with a peer-to-peer application. Cool.
Thank you so much, Max.
Thank you very much.